Hello and welcome back to Compiler Programming. I left off the last video with the very basic macro implementation working, so we can basically substitute a couple of tokens with some other token, and that's all that is happening, but that is a good starting point for today. And today the goal is to make this stuff work. In particular, the idea here is that we would capture whatever is the token at this position and then expand it over here. So we would say negative x is minus underscore x. So we basically just replace it with the minus stuff. Okay, let's try to make that happen. So we say negative 42. So ideally, when we get to 42, we would get the negative underscore x will get value 42, and we need to somehow replace it here. And this is sort of an easy case, but imagine that we have something like that. So eventually we will probably need to do it recursive, but let's start with an easy one and continue further afterwards. So this is the main rewriting routine, lots of nested loops, but this is just approach I decided to take. It's not very efficient, but it is something that we can use for now. And this is a to-do, and that it needs to be resolved now to make sure that we somehow identify what was at the position of underscore x. And the way I'm gonna do that is that let me refresh my own mind, because it's been a couple of days since I recorded the last video. So what do we have inside pattern? I guess I need to go here and look for macro, and we have these pattern names, and pattern names is exactly what? Okay, so if we start with this thing, then we do, and actually it's not in underscore x, it is just x here. So yeah, that makes sense. Okay, so basically we have an array of pattern names, and if the slice length is not 0, then we need to do the replacement. Okay, that seems pretty straightforward. Now we will need to have a map essentially from the name so from the slice to the token. So this is something that I guess has to be created. So we have this hash map slice template that is for scope, and we need to do something similar where we say that we have macro replacement map, and the value here is token star. So slice is a key and token star is the value. Okay, so let's make that happen. We would basically create the map here. Say hash map macro replacement map. Map is hash map make of macro replacement map, right? And then for standards U64J, actually I think I straight up want to move this stuff into a different method. We would call this void token rewrite macro match. see what we need to pass as parameters, but what it will do is the following. And the match, so we definitely need to have this stuff, right? And we also want state and macro. So state and macro star macro, right? Something like that. Let me remove this stuff and see if that builds. Of course, I also want to actually call this function here. Token write macro match state macro match. Okay, that builds, but obviously it will not do the right thing. So we have this replacement map here, we make it, and at the end of the function we destroy it. So we say hash map, I think it's called hash map destroy probably, of map. Okay. Now, what do we put in that map? Well, we go through the match, right? Actually, we go through macro pattern names. So we say I less than dynamic array length of macro pattern names plus I. Now we say slice star name is dynamic array get of macro pattern names I, and if name length. So if there is a capture there, so if like if I go here, this will not have a name, but this will have a name. Okay, if there is a capture, then we put that in a map. We say hash map set name, and what does it need to do? Well, the replacement is dynamic array, actually star dynamic array get of match at the same position. So pattern names and match need to have the same length. So maybe we should assert that just to be fine. Assert that this length is the same as match. Okay. Well, we need to actually provide the map. So I forgot the first argument, and this is like this. Okay, so we would set this replacement in the special map, and now what is left to do is here, instead of just verbatim putting the replacement into the tokens, we want to go through it, as I said, recursively, and apply this macro replacement map. So let's do that. Say void token apply macro replacement. So this is an array, and actually it needs to return an array because it mutates it. So array token pointer. This is the replacement, and not just that, but we actually need to clone it, because otherwise we will end up with, like, the first time we use a macro, everything is going to be fine, but then it's not going to be. So maybe let's start with that, and I will copy this and I will roll back the test. Maybe I will even, so first of all, this should work still. If I haven't messed up anything, this needs to pass, and it does. And say we say without a capture. And now I will copy this test and I will actually add one with capture, and I will say that we have this negative x, and I say negative 42, and then here I expect to have negative 42. Okay, I will even comment out this stuff because, as I said, the first thing I want to do now is to clone this replacement. So we will say token clone tree of macro replacement, and yeah, token clone slice, maybe. I don't know how to call it. Slices is overloaded term in because I call slices strings essentially. I'm not sure how to say token clone token array deep. Let's be verbose. Array token pointer, yeah, and this is the name of the function. This function accepts an array, and here's what we do. We say array token pointer result is dynamic array make of array token pointer, and we say that capacity is match dynamic array length of match, something like that. We return result. I said result. Okay, now we need to iterate over this. It's not even a match, this is like source, so let's call it source, and now we say token star token is dynamic, basically this, right, of source. And then depending on the type of that, we will need to do slightly different things. So let's say that we switch on token type, and I could probably find some place where we already do that, so that seems fine as a base to work on. Depending on type, if it is id, integer, operator, string, so all of these, what is it, token type value, lazy function definition, yes, something like that. So these should not happen, basically. Not reached. Because we are running macro as a first step, we should never have the situation where we have a token value at this point, I think. Okay, I'll just say not reached, and we will figure out later if we come across this why this is the case and change it accordingly. Anyhow, for these types of tokens, we don't need to recursion to them, so it's very easy. We just say dynamic array push of result and token. This is as easy as that, but here we actually need to do some things. So we would say copy is temp allocate of token. Then we say that copy is copy is original token, so we just copying. Switch somehow to Russian. So copy is token, but we do need to change the array of children, and copy children is going to be recursively calling this function. So we say token children, something like that. And now we push the copy. We could copy these ones as well, but we don't really mutate them, I guess. So we probably don't need to, although it might be safer to copy them. So let's do that. And then I will move this stuff over here and say nothing to do. And here like this. That seems reasonable. Except for forgotten star over here. So this should still work as it was before. And it does, which is great. But now we are ready to finally do the replacement. And the way this is gonna work is we will have basically the same setup as this, where we need to recurse over this stuff. Maybe I should actually merge these two things. Yeah, maybe I should merge them. So the method will be token apply macro replacements. It gets this array. It also will need to get this macro replacement map, and then there will be nothing to do for these types, but for ID there's going to be a special treatment, and that treatment is going to be, we'll say that if or like this, slice name is token source, if hash map, so we say tokens token star replacement pointer is hash map get of map name. So we basically just to clarify what I'm doing, is we are inside of this token array. And I'm going through it and I'm checking if I got an ID. So in this case, it will be just this. And if it is an ID, then I would replace it with whatever was on this position in original match. So in our case, it will be 42. Okay, so we have this replacement, and I say if replacement pointer, then star copy is star star replacement pointer. That's a lot of indirection, but basically we instead of copying the original one, we are copying the replacement. Okay, that seems fine. I will keep the straight up copy for now, and then it might prove handy later on. So we now can do token apply replacements. Maybe I should reformat that slightly so it is easier to read. And we pass on the map and macro replacements. Okay. Let's see, first of all, if you haven't broke the previous stuff, and previous stuff does work. And now the moment of truth where we try to enable this. Let's see what happens. Whoa, could not reduce an expression minus. So let me check. Okay. Well, first of all, I want to extract this here and say array token pointer replacement is this stuff. Replacement. And I will open trusty Visual Studio and see what is going on. So I'm looking for this method, right? Actually, I'm looking for this, and we'll see what is happening. Okay, I already see the problem, and maybe that's all there is. Here we shouldn't be pushing token, we should be pushing copy. Let's see. And indeed that all it was. So that's pretty cool. That means now that we can actually take these and resolve them here. So that's completely equivalent to when you have a function like macro in C. So that is basically equivalent to say negative x is minus x, right? This is what it's doing, and it has majority of the same shortcomings as C macros right now. So basically x will be evaluated multiple times because it's just a straight up substitution, and I think that is okay for certain scenarios. It might not be okay for other scenarios. I'll see how it evolves over time, but for now that is what it is. Since this worked out pretty well, I want to add one more thing, and this is the original usage for the macros, which is while loop. Use a macro for while loop. This is where things get a lot more complicated. So, while loop, how does it look like? Well, we have while, and then we have condition, and then we have body, right? Okay, let's try to make that happen. So let's look at how it was implemented here. I will just take that stuff and I will put it over to here and try to make it work. So this is not required. I mean, it will, but it will be in the main code. So maybe I'll just move this here and comment it out. This is where it would become a problem potentially with the fact that macros are unhygienic. So if you would already have a loop label defined, then you would have a conflict. So this is definitely something that has to be taken care of eventually, not right now. And here I will need to put condition. So maybe if will need to require parentheses, maybe not, I don't know. So how does it work? Well, we would need to change how this does. So it's probably like this, and this is where the body goes, right? Does that make sense? Let me recheck. So we create a label, there is an if condition passes, we go into the body. Maybe I should do semicolon here just to be safe, because even if it's going to be an empty statement in the end, that's okay. And then we repeat the loop, which will again go to condition, and if condition fails, we just fall through and we stop evaluating this whole setup. So something like that should work. Now, this is the definition of a while macro, and now we need to make the usage of it. The usage is as follows, right? We have a sum, and then we say while, what was it? X less than, okay, we pass in the X, okay. So I might not want to copy this sum up to stuff, right? I say X is more than 0. Okay. X is more than 0. I do these things. And at the end, so we need a semicolon here, and then they say return sum. So this is quite complicated. Let's see what is going to happen. I do need to change the setup, so this is now, I basically need to copy this thing, right? This is the same test. Okay. Well, let's try to run that thing. Okay, we got big fat not implemented. Where does that happen? Let's check that. So 779. We are trying to force value which we have no idea what to do about. Okay. I guess that would be a block. But let's verify that. Oh, I mean, it is a block. So let's just fix that. So else if this is gonna be curly, right? What's gonna happen with curly? Well, essentially what we need to do is just move the code that right now is specific to the function implementation and move it here. So function force lazy function definition. I think that's what we want. Yep. And we have this token parse block, and this is the result. So that's pretty handy that I already thought of that. And like this, right? So we have value and we will just return it. That seems pretty straightforward. I can actually just straight up return this. Token parse block undefined, because it is defined only here. Let's just do forward declaration of that, or even put it inside of source H. Why not? Okay. So this is not a function scope, this is just scope, and it's not builder, this is builder, and token is that. Okay, let's try that again. Okay, could not resolve identifier condition. Well, by the time you got to condition, you should have not had it. So that means that our routine for replacing this stuff didn't really work. So it worked here, but it didn't work here. And the difference is in the... I think I know what's going on. That is because I'm calling the wrong function. Here it's supposed to be map. Yep, that sounds good. Let's try it again. And could not resolve identifier if. Okay. That is interesting. Why does it try to resolve identifier if? Okay, and now it's definitely the time to break out debugger and see what is happening. So we are trying to look up if. Where are we coming from? We are coming from token rewrite function calls. Oh, that is unfortunate. So here's what's happening. Right now, when I'm looking for a function call, I'm just looking for an identifier followed by parentheses. And this is not that. This is a special keyword and special statement. So this is where I end up with probably need to do some refactoring on how expression matching works again. But let's see. So let's start with token force, whatever. What was the name of that thing that we used? Now underscore block. Okay, so I have token parse block, and basically it goes through the block and it does token match expression and token match expression. Yeah. So this, I think, this is quite awkward. For things like if to work, I will either need to change the matching to allow like arbitrary ranges, or I need to slightly change what it matches in the first place. So for now, I'll just take this stuff out and I will put it over here and see what that brings me. Probably nothing very good. Unless I also do the following. So let's go to if, and here in the condition, I would now say that it has to be a parenthesized expression. Okay, tick, 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 tick. That is good. Yep. And where is this stuff here? So here I would have to say like that. It is definitely not a sustainable thing long term, but I don't want to go very deep inside into this stuff. So we are still having problems with ifs, and more so it's actually and this that fails, I think. Yeah, so maybe we don't. Let's check. Okay, could not reduce an expression x. Where is that happening? First of all, I have to test with the same name. This is waste capture and this is the while loop. Okay, that's not really important, but just nice to clean up. It still complains that it could not reduce an expression. Okay, let's break out debugger again. So we have state tokens. There are 2 of them. Actually, no, there are 3 of them. And I will need to... how do I do that? Maybe copy. So this will be state tokens. Okay, so it had no idea what to do with with this stuff. And that is because I think I don't actually have, yeah. So that's a very easy problem to solve. We have somewhere this stuff, right? We have less than, and we need to have greater than. This is greater, and here I just say it's called more or greater. I don't know. I guess it's called greater. Yep. Let's see how that works now. It still complains that it could not do that because we actually didn't include this into here. Whoa, great. So we have a while loop. There is definitely some reworking needs to be done again in this area. And I was already thinking about it in the back of my mind. Basically, yeah, these kind of statement things, they should be captured. They should be rewritten first, and only then their parts will be evaluated. It also will help alleviate the problem with the ordering of things and things being forced when they shouldn't be. But again, this is a separate topic altogether and is not important for now, because for now we were focusing on the macro, and the actual expansion seemed to work just fine. So right now we have a very nice while macro, and unlike basically any language that I know of, this is not a built-in construct, right? And this is very, very, very nice, because you can extend it however you want, you can change it however you want, and you don't have to have special things for it inside the compiler. With that will be it for today. I'm super happy with the progress. There is definitely lots to clean up and lots to do, but all that will happen sometime after. Hopefully, see you next time. Bye bye.